Hi everyone. Today's lesson is dividing numbers in scientific notation, but let's start with a review. Express the number in standard form, in scientific notation, and multiply. Can you please pause and do these problems so you can see where you are with your learning? Alright, the first one, expressing numbers in scientific notation. Remember, the exponent tells us how many places we move the decimal, and if you're multiplying by a positive power of 10, the number is going to get bigger. So 6.13, we have to move the decimal 6 times because we're multiplying by a power of 10 6 times. 1, 2, 3, 4, 5, 6. And then you add zeros to hold the place value and rewrite with 4 zeros. And then you put your commas in so it looks nice and neat. And then I always check. It was right here, and the decimal was right here, and we had to move it 1, 2, 3, 4, 5, 6 places. Remember, a common mistake is thinking that the number tells us how many zeros there are, but notice there's only 4 zeros because there are 2 non-zero place values when we are moving our decimal. Second one, expressing the number in scientific notation. Now this is the opposite. Now we have to make the decimal times a power of 10. So the decimal times a power of 10. When we move our decimal, we want to move it so when we stop, the A, or the decimal, is a number between 1 and 10. So 3.7. So there's always going to be one number that's not a zero before the decimal point. And it's going to be times 10 to the, and how many times do we move that decimal? 1, 2, 3, 4, 5, 6, 7, 8 times. And because we had a very small number, our exponent is going to be negative. I always double check. 1, 2, 3, 4, 5, 6, 7, 8. And lastly, multiplication. Remember to multiply. You regroup, so 3 times 2.5 times 10 to the 5th times 10 to the 3rd. And then if you need to multiply off to the side, you can. 3 times 5 is 15. Carry the 1. 3 times 2 plus 1 is 7. And there's only one decimal place in the problem, so there's only one decimal place after, or one place value after the decimal in the answer. 7.5 times 10 to the, and when we're multiplying powers with the same base, we add the exponent, so it's 10 to the 8th. All right, dividing is so similar to multiplying. We multiplied the numbers, now we're going to divide the numbers, and we multiplied the powers of 10, and now we're going to divide the powers of 10. And remember, when you're dividing powers of 10, you subtract the exponents. So 9 divided by 3 is 3 times 10, and then when we're dividing powers of 10, we subtract the exponents. So I'm going to write that down here. 15 minus 8 is 7, so my new exponent is 7, and it's that easy. 5 divided by 2 is 2.5 times 10 to the, and then when we are multiplying powers of 10, we subtract, when we're dividing powers of 10 with the same base, we subtract the exponent. So it's negative 8 minus negative 4. Remember, keep, change, change. If we have unlike signs, we subtract, and there's more negatives, so my new exponent is negative 4. Try the next two and see if you can get the answer. So pause, try, and then check back. Okay, so let's see how you did. 4.8 divided by 4. If you need to, write it out like that. 4 goes into 4 one time, put the decimal up. 4 goes into 8 2 times. So my decimal portion is 1.2 times, and if we're dividing powers of 10 with the same base, we subtract the exponents. 8 minus 5 is 3, so my new exponent is 3. By the way, one of the most common mistakes I've seen is changing this division problem into multiplication. This line means division, so you're never going to multiply if there's one of these lines, unless there is something both in the numerator or the denominator. All right, very last one. We are going to divide. So again, write it out if you need to. 1.5 goes into 4.5 how many times? When you're dividing decimals, you clear the decimals. I had to move it once here, so I'm going to move it once here. So my new decimal is right here. 15 goes into 45 3 times. So 3 times 10 to the, and then we're multiplying powers with the same base. Sorry, I keep saying multiplying. When you're dividing powers with the same base, you subtract the exponents. Keep, change, change. When they're unlike signs, you subtract, and there's more positive, so our new exponent is 3. All right, for these problems, you might have to change to scientific notation. The last set of problems were all in scientific notation, but remember, every single time you do an operation in scientific notation and your answer has to be in scientific notation, you need to double check to make sure that the decimal is between 1 and 10. So we are going to divide. So 8 goes into 2.4 3 times. So it's 0.3 times 10 to the, when you're dividing powers with the same base, you subtract, so 9 minus 3 is 6. So now I'm going to look, is it in scientific notation? Well, this number right here is not between 1 and 10. Remember, it needs to be at least 1, but less than 10. So we need to change that decimal, so we're going to move it over once. So now it is 3.0. And if you make a really easy way to remember this is if you make the decimal larger, which we did, the power of 10 has to get smaller by the same number. So we made it one place value larger, so the exponent has to go down 1. So now we have 3 times 10 to the 5th. If you cannot remember the rule, please, when in doubt, write it out. Write out what this is in standard form and then change it back into scientific notation. All right, the last example. We divide the numbers, so 6 goes into 3.6. 3 goes into 36 6 times, so it's 0.6 times 10 to the, and when we are dividing powers with the same base, we subtract, so we have a 6. It is not in scientific notation, so we have to move the decimal over once here to make it 6 times 10 to the, and since we made the decimal one place larger, we have to make the exponent one place smaller, so it is 10 to the 5th. We out.